Ready?
Yeah.
Coming to you from Charlottesville, Virginia, WillowTalk. With your hosts, Andrew Carter and Ben Fry.
Ben.
Andrew.
I got something for you, man.
Do you? Is it interesting and cool?
I hope so.
Funny?
Let me show you this thing I found on Reddit. This is like every other conversation we have in our lives.
Yeah, pretty much everything comes from Reddit.
Everything. If it doesn't, it came from Twitter, maybe. So this thing, Subreddit Simulator, is one of my new favorite subreddits. When I first discovered it, I had a hard time figuring out, like, is this a bunch of bots posting stuff? Is this people pretending to be bots? Because it all, like, feels really, really real. But after digging into it, let's just take a look at it real quick here. So we'll have, Subreddit Simulator is the subreddit. And if you look real close at the different things that are posting, we have, food_SS. Or all top today SS. So this is food subreddit simulator.
Right.
So what's happening is these posts are made by bots using what's called Markov Chains or Markov Chains, and they take a source text and they kind of learn about that source text and then are able to generate other sentences that have the same kind of feel because they're making text based off of that other text. So when I first discovered this, I'm like, man, this must be the most crazy computer sciencey,
right.
Super hard to do.
It sounds like it would be fairly difficult.
I didn't even look into it because I was like, this is far beyond me. But it turns out one of our buddies here at WillowTree wanted to do a Slack simulator. We could simulate some of our Slack chat rooms.
Yeah.
And I told him to look into it. Then after he looked into it, he told me how the Markov chains work. And I was like, oh my god, that's the easiest thing in the whole world. So I think just to kind of where was the what is Subreddit Simulator? So they go into how it all works and how the submissions work, and basically they bring up the so they're all using these Markov chains. So what a Markov chain is given a bunch of source material, it's able to generate. It's almost like a pattern kind of thing, right? Where I think I was looking at the Wikipedia page of Markov chains.
It's more of a mathematical
right?
thing.
It's a mathematical thing, statistics kind of thing. It was made by a Russian mathematician. And the kind of best, easiest example...
Andre Markov.
Or Andre.
Is the best way to pronounce it.
We don't know Russian. Where's the best example that I saw was not the popcorn one, but the drunkard's walk. So if I can search the word drunk, here we go. So this is a good example. So given so the idea of the Markov chain is you don't really need to know. Just given the current state of the chain, you should be able to keep on going, right? You don't need to have any, a lot of information. So a good example here is that, if you have, if the drunkard's walk is he's going to either take a step forwards or take a step backwards.
He's stumbling about.
Right, so there's the probability, it's a 50-50 chance of either he's going to stumble forwards, stumble backwards. You don't need to know how he got there, you don't know the part of the machine. You can just, given the current state, he's either going to, right, you can simulate the next step. Or, again, they're saying, dietary habits of creatures, of when they eat. Or there's all kinds of good examples, like gambling. They use, popcorn machines for, whether popcorn kernels are going to pop or not. And they give, a non-Markov example, and that's where, statistics, probability does start to matter and change, where, you need to know what's happened before in order to figure out what's going to happen next.
Okay.
Anyway, enough with the boring science stuff that we don't understand anyway, but into the fun part. So if what our goal is to make hilarious new sentences using Markov chains, let's just go into how it works.
Okay.
So we're going to do this in Swift. It doesn't have to be done in Swift. I, in fact, think the one that the Subreddit Simulator does is written in Python, I believe. And Python's a much easier language for working with text in general than Swift is, but I know Swift, so that's what we're going to do. So the first thing you need to decide is what kind of text do you want. So that Subreddit Simulator is using subreddits.
Yeah, do you know, are they just pulling from the other subreddits that are on Reddit?
Right, I think each bot is pulling from its own, the...
grouping of them?
Right, so a chain generated off of, the food subreddit will have lots of food kind of words in it, because that's its data source. So it's kind of fun, even go back to this real quick. Reddit subreddit.
Now, is that Subreddit Simulator, is it simulating a whole slew of subreddits, or is it
it's basically it's one subreddit by different. So if we take this, so this is a post by fitness subreddit, but if you dig into it, the comments are also by bots. So let's say the Dungeons and Dragons subreddit simulator is going to have words NPCs, that's a word from Dungeons and Dragons, right? So all the comments by bots that are using subreddits for their source, and the posts are by bots using a different subreddit for their source.
Hilarious.
So it's amazing. So I wanted to do this myself. So like a fun thing to do, like there's a good one on Tumblr where it's a Tumblr account that takes, I think it's a book of Genesis and then a programming manual to make like a programming commandments kind of thing.
Yeah.
So what I decided to look for this case, I've got this text document here. I've taken the first article of the Constitution and I've taken a bunch of Papa John's promotional marketing text.
That should lead to some pretty good stuff.
So we'll get some like constitutional pizza stuff going on here.
So is there like, it sounds like having more text would be helpful. Is there like a lower limit on what seems to be useful or,
I was looking
a sweet spot?
Right. So if you have if you're going for, like I'm always going for comedy.
Right.
So I want like, if we took the entire Constitution and then just a little bit of Papa John stuff, we'd probably end up with mostly Constitution-y sounding kind of words. So you want a good mix. And there's like, the nice thing is you can kind of be as fancy or as not fancy this as you can. Like in another version of this thing that I've made previously, I've made it so that it like requires the word pizza, or like maybe it tends to favor words. You can make it be more leaning in one direction, but we're going to be nice and fair and even here with these two pieces of text. So we've got kind of like a half and half of Constitution and Papa John's. Let's get started.
Cool.
So the boring part is we just need to get this text loaded up. So to do that, we need to get the path for the text file we have. URL for resource. Let's get the path for resource. So we want our text document. There's no type. There's no directory. And since it's a demo code, we'll go ahead and be dangerous. Same thing with our string. So let's call it text. So let's load up this from the file. Contents of file path. I think we can just leave that out. And let's make sure this works. So again, all we're doing here is just loading up the text, putting it into a variable. And if we're lucky, it'll work. It did. So again, there's all of our text. Cool. So with the Markov chain, basically the way this is going to work, so with the whole drunkard's walk kind of thing, that was, you knew the two things that could happen. He could either step forwards or he could step backwards, and you just at random picked one of them. Well, with text, basically the way that people set this stuff up, and again, you can make this fancier, but for our simple example, what we're going to do is take the word like the. So this word is special because it's the start of a sentence, so that kind of matters. So we're going to keep track of whether things are the start or end of sentences. Okay. So the sentences we generate will only start with words that our source materials sentences started with. Same thing for ending. But the trick is to look at like the word the, what words usually come after the word the. So what we want to do is figure out, basically just that. Yeah. So we're gonna create a dictionary essentially of saying for the word the, here's all the possible words that could come after it, and then we'll just kind of at random pick one and roll with it. That's sort of
where the chain part.
Right, and that's the chain. That's the chain. So and they call those, I think they call them transitions in the actual Markov, like the statistical
when
model.
You go from
it's
one
a
word
transition
to the next one.
Yes, and I guess you have like a certain the probability happens with certain transitions are more probable than others. So with our word the,
like the was followed by Philly cheesesteak 15 times.
right. So like the more often it occurs, the more it's going to happen. And in our case, we'll be kind of dumb about it, but it'll work out better. We'll just keep track of like if the word Philly cheesesteak happens after the word the 10 times, that will appear 10 times in our array of possible next words. So it will have a higher chance of happening.
I see.
Right.
Okay.
So let's call, let's make a struct here. We'll call that.
So you'll get the probability for free out of that.
Right. So we just get the probability. So what we care about are starting words, which is going to be a string or an array of strings. We care about things that are ending words, which is again an array of strings. And then we care about what we'll call transitions. And that's going to be for a given word, here are the possible words that can come after it. So transitions is a map of strings to arrays of strings. So again, for the word the, we could have the and then like apple or the pizza or the friend or whatever it may be. And again, we'll know where sentences start by keeping track of the starting words, and we'll know where they end by keeping track of the ending words. So that's what we want to have in our little data source here. So what we'll do is give ourselves an initializer where we can get to the text, and then we'll initialize all these variables. So what we want to capture from this text is all these starting words. Well, in fact, let's just do this. So, and we'll just append to these guys as we digest our text here. So that's what we want to know. And then once we've got it figured out, we'll set our properties to be what we got. So few problems. We want to kind of clean up our text a little bit, right? So we make our new sentences. We don't really want to care about new lines. We don't want to care about capitalization, that kind of thing. So let's clean up our text a little bit. So we'll call our clean text. So let's take our text we got. Let's lowercase it. And let's replace new lines with an empty string. So that's just going to make it so our source material is a little bit easier to reason about. And again, because most languages are case sensitive, if you're keeping track of like words that come after the word the, capital V is different than lowercase v, but we don't want that to be the case inside of we want to normalize it, right?
Would it make more sense to replace new lines with a space so you don't get words slammed together?
That could be it. We're going to get rid of spaces.
Oh, okay.
But this actually might fix a few edge cases, so let's do that. So now what we want to get is sentences, right? So we'll say sentences. So what defines a sentence usually?
Ends in a period, exclamation point, question mark.
Right.
Something of that set.
So let's go ahead and make a character set that represents... Help me out, buddy.
Punctuation.
Yeah. There we go. Characters in... So let's call it exclamation point, question mark, and period. So those will be all of our... So these will be the end of a sentence. Okay. So we'll say sentences are going to be our clean text separated by our character set here. Hopefully. Help me out. There we go. Cool. So now we have all the different sentences inside of our source material. Nice. So now for every sentence, we want to figure out what the starting words are, what the ending words are, and then the transition between the words inside of it.
Sounds like you're going to leap over these guys.
It sounds like it. So for each sentence. Cool. So we want to grab the words, right?
Right.
So we'll say words equals sentence dot separated by, in this case, we're going to do a space. Cool. All right. So we'll do words. So the trick is here, we want to keep track of the ending and the beginning. Right. So the easy way in Swift to do that, if you just do a for each for every word, we're not going to do the index of the word. Right. But if we do an enumeration of them, that's going to give us the index as well. So we'll do for each. So in this case, we're going to have the offset and the word. Beautiful. So now, again, we want to keep track of the starting word. So we'll say starting words dot append the word. We've got the starting word. So
don't you want to check if it's?
Oh, right.
If your index is.
Of course I do. So if offset is 0, there we go. Beautiful. Okay. Now, if the offset is equal to the words, let's calculate the count once, that we don't have to do it all the time. Words count equal words dot count. Beautiful. So if it's equal to the words dot count minus 1, double equals else. All right. So if it's the last word, we want to say, we're going to call it ending words dot append word. Cool. Now, otherwise, we want to basically keep track of this transition, right? So what we can do here is say the transition is going to be transitions, object for the key word. And if we don't have one yet, that means that we need to make a new one, right? So for the transition, we want to append. So we don't want to append the current word we're looking at, we want to append the next word. And some people in their Markov chains will not only append the next word, but the next 2 words. So you can end up with some less zany sentences.
Right.
If you the more, you can add some more sanity to it by keeping the things more structured to what the source text was. But it's kind of more fun to make it more goofy. So we're just going to do the next word. So we'll say the words at the offset plus 1. And then we have to set this back to our...
Also, I would think the more that you're caching ahead, the larger the source text you would really want to have.
That's true.
Right?
Yeah, that makes sense. Because you have more variety that way.
Yeah.
And I don't want to do... No, that's right. Oh, this should be...
Transition.
It's var. That's what the problem is. Not car, but var.
You keep trying to make it a car.
I do. All right, I think... That should do it for that. Let's look at this real quick. So the words, we're not using words count. Why aren't we using that? Right, because we can just do this right here. There we go. Okay, beautiful. Okay, so that should do that. So now we've got our data source. So that's great. Now we have a way of knowing what our starting words are, what our ending words are, and what words come after other words. So that's great, but now we need to be able to actually make a sentence out of that.
Right.
So we're going to make a class, which we'll call a sentence generator. All right, and that needs to have a data source, right?
Right.
So let's make an initializer with the data source. Self.data source equals data source. Nice. Okay, and then let's make one function, which we'll call make sentence. And that's going to return a string. Cool. So now we got the sentence generator. We need to be able to actually make this make sentence do something. Right. So the first thing we need to do is figure out what the starting word of our sentence is going to be. So we're gonna as we build our sentence, we're gonna do it by accumulating an array of words. Okay. So let's go ahead and get that ready. So this is where we're gonna keep all the words for our sentence. So for the starting word, we're going to grab a random starting word out of our data source's starting words. So we'll say data source, and this is going to be a int arc for random modulo.
Don't you need to? You mean on the starting words in data source, right?
Yes, you're right. Data source dot starting words dot count, and this needs to be a uint 32. Good old types. All right, there we go. Cool. So that's going to give us basically what we're doing there is grabbing a random word out of our data source's starting words, and let's go ahead and append that to our array of words. Cool. So now what we want to do is keep on transitioning to other words until we end up at one of our ending words. Right. So using the hilarious fifth syntax of the repeat while. So we're going to keep on appending while, ready for this? Let's get fancy right here. So we need to figure out if our last word that we used is inside of our starting words.
Ending words. Right?
Ending words, yes. So the last word we used is an optional, so we can't check to see if it contains that, but we can flat map that to see if it is. So we can do. So we're going to take our last word. We're going to lift it into a non-optional.
Very functional.
Right, look how fancy this is. So we're going to say data source dot ending words dot contains. I want to make sure that it doesn't contain this word. Right. That's what we want to repeat. So in this case, money sign 0, default to true. We're just going to keep on going. So let's make sure this compiles. This will return. All right, and so I need to return my string.
Well, you also need closing brace under.
No, I think we're good. Well, let's see.
Oh, I see.
Yeah, we're good. Cool. So we'll put our actual return value there once we get it. Okay, so what we need to do is grab a transition word. So we'll say we need to get our current word. So we'll say guard let last word equal words dot last else. So what we're going to say is if we don't have it, this really shouldn't happen, but in the case where we don't have a word, we're just going to break and let that into our sentence. So right. And another thing we need to also make sure is that we have a transition.
Yeah, that's what I was going to say.
The next word equals data source dot transitions for our last word. All right, because it's possible that we don't actually have a next. There's no transition for this word, in which case our trains. And again, you could be more smart and try to find a way to recover from that scenario. But in our little simple dumb chain here, we'll just roll with this.
So I'm not sure how you would get a word that didn't have a transition unless it was a last word, right?
I guess you're probably right. Yeah,
but you could get yourself into a loop where you never hit a last word.
Right, that's true. Well, hopefully that doesn't happen. All right. So we've got our transition. Again, transition is a string. This is an array of strings.
Right.
So this is given our last word. Here are all the possible next words according to our source document there. So we'll say let new word, and again we're just going to steal it from this right here, so I don't have to type all that again. Equals transition, and this is going to be our transition dot count. And cool. So again, a random word from our transitions is our new word, and then we're going to append that new word to our list of words.
Gotcha.
So now...
And so, so it'll break when it reaches the last word because the last word won't have a transition. Well,
right.
That's not true. A last word may have a transition. So how are you checking to drop out when?
Well, that's this right here. This repeat while. So if
it's in your while.
So if
there you go.
In that while, if the last word we used was in our last words, then we break. So now we can actually turn this into a sentence. So what we'll do is we'll take our words and we'll join them with a space, and we will capitalize it because it's a capital sentence usually, right? Capitalized, and then to add a period. Can we just do a plus period? Does that work?
You always do period?
Yeah, why not?
You could randomize from your punctuation from before.
That's too fancy, man. We'll use an exclamation point. That way it's exciting.
There you go.
Okay, cool. So I think as long as there's no bugs, that should do it. So let's use this thing. So let's make a data source. And give it the text. And then we'll let our generator equal a sentence generator with our data source there. That should do it. So let's make a few sentences here. So let's do 100 of them. There we go. All right, let's see if it works. It did.
Oh, a lot of blanks.
Oh, you know what? Let's get rid of... Did our new line...
I guess if your starting word is also an ending word, it would do that.
Right, you're right. Yeah, so there's, and you know what? And it looks like there's lots of, those exclamation points are goofy, but it looks like this worked for the most part. So we could probably clean this up, but let's take a look at just what we got here, right? If I can find a way to get rid of this other panel, there we go. Well, there we go. This text is kind of small. Let's take this and put it in a bigger text document. So again, we can make this fancier, smarter, better, but I think we'll get some good results out of this. So you might think that this is going to be a super hard, fancy, computer sciencey kind of thing.
Right.
That was pretty easy. Let's take a look and see if these sentences make sense. So let's see what we got. I was growing up, my 2 newest addition to order. So that it almost looks like real sentences. I found the craft of weights and under the writ of naturalization and CEO. The double chocolate chip brownie. Greatest creation, the price. Oh, this is good. Yeah. Showing fans customized an extra virgin olive oil, cold filtered water, sugar, salt, and yeast, and greatest creation, the price. Here's good. Here's some constitutional stuff coming in. The Senate, but in the hot summer on the new grilled chicken, and who don't want to regulate the holiday season or too hot new Greek pizza. So again, we just in roughly 50 lines of code, we've come pretty far.
Yeah, and we can obviously add more logic to clean this up. We can look cleaning up the blank sentences, or
we can add different kinds of punctuation. We can make sure there's a noun, make sure there's a verb.
Yep.
We could give a mandatory length or a minimum length.
And you also have a very short amount of C.
Yeah, this is a lot of information.
The larger the stuff you have, the more variety you're going to get.
Right.
And better options you're going to have. And served on the Congress.
Judgment and can be entered on 2 houses shall be assembled in the deal. These days,
better ingredients, 2/3 representatives according to Dump with the Brain. That's always there. That's good.
So you can get some really cool stuff. So we've had families are available for $5.
Oh,
amazing. So yeah,
national pizza.
We can when we first discovered this, I think we spent 3 hours just going through and making sentences. So it's fun to mix in a programming manual, mix in we did some Zen cones, we did some Papa John stuff.
Yeah.
There's it's just so much fun to sit down and mess with this and try to tune it, make it better and better and better. And again, you can look at the Subreddit Simulator to get ideas of what a really good cleaned up Markov Chain generator looks like. But for this much code, this is a pretty great, it looks so real and it looks like it's actual sentences. So I was thinking of other cool applications of this would be maybe video game AI. If you wanted to make a...
So that's what I was going to say is this is silly and hilarious and fun to mess around with, but
there's actual
what are the practical applications?
So a few cool ones I've seen are Google does this with page ranking. So when it tries to rank a website, it will, I'm not sure how it applies this, but it does. Same thing for technology like Siri, voice recognition.
Okay, yeah.
If it wants to try to figure out as you're talking, if it didn't hear a word quite right but had a decent idea, it can look and see, here's right. It can make more smart guesses using the English language as source material. And so basically, it's a good aid to other more smart kinds of technology.
Cool.
And there's another cool use I've read of it.
I imagine what it plays into machine learning.
Right, machine learning and music generation. I think that's the one. So like if you want to do some cool like lots of things in life are patterns, and this is a cool way to basically generate patterns given a bunch of source patterns. So if you want to like random generated music, randomly generated like dungeon mazes or something, like there's all kinds of cool uses, and it's so darn easy to do. That's the coolest part about it. There's nothing crazy fancy about it. So that's all I got for you, dude.
Cool, man.
Yeah. So if anybody has any other cool like examples or uses of this, or like really fun ways to make this better, let us know. I'll take this and put it up on GitHub in a link somewhere, so people want to play with it. You'll have it available. But we had a big kick playing with this and making some great sentences, so it's a good way to waste time, if anything else.
Yeah, super fun.
There you go. We'll call that a big, spicy pulled pork pizza.